Hi everyone. In today's POTD, you can get the big O of n square solution from anywhere. Most of the videos are talking about big O of n square solution only. But in this video, I'll talk about only the big O of n log n time complexity solution, which is most optimized answer for this problem. Okay, I'm assuming that you have read the problem statement and understood what you have to do. Okay, I'll just straightly jump over to the solution. First of all, we will store tails of previous LIS captured. Now, what does it mean? Obviously, we have to traverse in the array, right? Let's say this is my array. This is the array given, and you by traversing the array, let's say at any intermediate state, you are at index I. So this is my full array, and let's say I am at index I. When you are at index I, you have traversed from 0 to I minus 1, right? This is here I have index 0, here I have index n minus 1, and I'm talking about at any intermediate, or you can say at ith iteration of my loop, I am at here and I have traversed this part from 0 to I minus 1. Now from 0 to I minus 1, we may have encountered increasing subsequences of many length. From 0 to I minus 1, you may have encountered subsequence of length 1, increasing subsequence, okay? Increasing subsequence of length 2, increasing subsequence of length 3, increasing subsequence of length 3. There are many possibilities, okay? We will store tails of all those increasing subsequences. Let's say in my 0 to I minus 1 journey, I got these three length subsequences: length 1, length 2, and length 3. And the subsequence corresponding to length 1 is, let's say, A1, length 2 is, let's say, B1 and B2, for 3, let's say C1, C2, C3. So this subsequence, and obviously here B1 is less than B2, C1 is less than C2, C2 is less than C3. It is holding the property of increasing order, right? So I will store tail of all these increasing subsequences. Increasing subsequence of length 1, length 2, length 3. From 1 till max, the maximum length subsequence you are getting, till that point you will store tail of each length of increasing subsequence. How we will store that we will talk later. Right now we just have to understand this fact that we should store the tails. And why are we storing these tail? Let's say I'm getting an element AI here. I'm getting an element EI, let's say EI. I'm getting element EI here at index I. EI element is present. Now I will check, is EI greater than A1? Is it greater than B2? Is it greater than C3? If it is, let's say EI is greater than B2, then I can append EI here, and that will become a subsequence of length 3, new subsequence of length 3. So I can expand the previous subsequences. If EI is greater than C3, then I can append it here. That will become a new subsequence of length 4. If EI is greater than A1, then I can append it here. So to check that if I can expand a previous subsequence or not, I just need their last element. which I am calling tails. I don't need this B1, this C1 or C2, because if an element is greater than the last element of that increasing subsequence, then it will automatically be greater than rest of the elements. So we will just store length tail of every previous increasing subsequence. Okay. Now, one more thing that we need to understand is that we will store smallest possible tail for each lengthed previous subsequences. Now, while traversing from 0 to I minus 1, while traversing from While traversing from 0 to I minus 1, you may have encountered many increasing subsequences whose length is 3. Right? Let's say from 0 to I minus 1 I have traversed and I got the length of let's say I fixed the length to 3, then I may get different subsequences which have same length, right? From 0 to I minus 1, let's say I got one subsequence, let's say x1, x2 and x3, and I got another entirely different subsequence y1, y2, y3. This is also of length 3. This is also of length 3, and this subsequence has tail x3. This subsequence has tail y3. So which tail will you store to proceed further? You will store the smallest possible tail. Now, the reasoning behind it. Why are we storing the smallest possible tail? Because by storing the smallest possible tail, we will keep the scope of all possible answers. Because let's say this EI element is smaller than, let's say you here let me say that x3 is less than y3. So which one will you store? You will store x3 and not y3. What happens if you store y3? Let's say I'll store y3 and I will reject this x3. Now it may happen that EI that you have observed is not greater than y3. So you can't expand this subsequence by appending it here, because EI is not greater than y3. But it may happen that EI is greater than x3. So this subsequence can be expanded by this EI. So storing the smallest possible tail help us not missing any possible answer, right? If EI is greater than y3, then it will be greater than x3 also, right? But EI is less than y3, then it may possible that it is greater than x3. So in that case, storing this tail value, greater tail value, may lead us to miss some answers, right? So storing the smallest possible tail help us to gives us more scope of expanding an existing subsequence, right? Cool. So now you got the idea that why are we storing the smallest possible tail. First of all, you got the idea that why are we storing the tail value. Now I give you the idea that we are storing only the smallest possible tail value. Okay. Now one more thing. One thing that you observe when you store smallest possible tail from 0 to I minus 1, when you keep on storing the smallest possible tail, for each length of subsequence, one thing that you observe that you will get all these tails in sorted order. You will get all these tails in sorted order. Now, why am I getting these tails in sorted order? Give me the proper justification for that. Let me give you an example. Let's say you are using a vector to store these lengths, and let's say from you have traversed till index I, and now here you have element AI. Here you have element AI, and from 0 to I minus 1, let's say you got these length subsequences: length 1, length 2, length 3, length 4, and length 5, and let's say length 6 also. And let's say tail of a subsequence. So these are lengths. These are lengths. These lower labels I have written here. These are lengths. Okay. So indexing of that array is based on the length. So index means length. So I have mapped index to length. Okay, index means length. So for length 1 subsequence, let's say I have tail t1. Let's say I have tail t1, and for length 2 subsequence, let's say I have tail t2. Tail is the last element of that increasing subsequence of length 2. ठीक है? t3 is the length of that subsequence which is of length 3, and t4 is the length of that increasing subsequence whose length is 4. Similarly, t5 is the last element of increasing subsequence of length 5, and t6 is the last element of increasing subsequence of length 6. That we got from by traversing from 0 to I minus 1. Okay. Now we got a new element in picture. At ith iteration, I got this new element AI. Now we will see which subsequence it can expand. I will check if this AI is greater than this T6. If AI is greater than T6, AI is greater than T6. What will I do? If AI is greater than T6, I can expand this length 6th length subsequence. So in 6th length subsequence, here I have 6th length subsequence, and I will append A here. Okay. So this is of, here I have T6, and here I will I'll just place AI. Since earlier it was of length 6, now it will become of length 7. So for length 7 subsequence, I got new tail, and the tail value is AI. So what I will do, I will just simply make a new entry here for length 7 subsequence, and I will store the tail for that AI. You got it or not? We have from 0 to I minus 1, I have a subsequence of length 6 whose last value is T6. If I append AI, first of all I'll check if AI is greater than this tail value. The check condition will say yes, it is greater than T6. Now if AI is greater than T6, I will append AI to that subsequence, and on appending that, the length will increase by 1, and since its length is 6, the length of overall subsequence will become 7, and for 7 I have to make a new entry, because till now we didn't get any 7th length subsequence. So I'll make a new entry for at index 7 and I will place AI here, because AI will become tail of that new subsequence. Okay. Now what if AI is not greater than T6? If this AI is not greater than T6, so I will check, I will traverse in my all those tails. First of all I try to expand this T6 6 maximum length subsequence, 6th length. Let's say AI is less than T6. AI is less than T6, so we can't expand this 6th length subsequence. So I will go to T5. I will ask to T5, is AI greater than T5? So let's say T5 also says that I am greater than AI, so which means AI is less than T5, and AI again can't expand this subsequence of length 5. So I'll go to T4. I will ask, can I replace you? For that I will check, is AI greater than T4? Let's say T4 also says that no, you are not greater than me, I am greater than you. So I can't expand this. And then I will go to T3. I will say, am I greater than you? So let's say T3 say you are greater than me. So I will we got AI greater than T3. So here at this position we will traverse from here to there, and I got that AI is greater than T3. Okay, now I can expand this 3 length subsequence whose tail is T3. So we have something like this. We have a subsequence, increasing subsequence of length 3, and we only know the last element of that subsequence, that is T3. We only know the last element. We have no idea about these previous elements because we haven't stored them, right? I have only stored stored this last element, and that is T3. Okay, now this new element is saying that I am greater than T3. So what I'll do, I can expand by appending AI here. I will append AI here, and what will the new length? New length will be new length get increased by 1, so new length will be 4. So I got a new subsequence. Of length 4. And what is the tail of this new subsequence? Tail of this new subsequence is AI. So where should I place this AI? At index 4. And index 4 is here. But at index 4 I already have a tail T4. So I'll check, and since we were storing only the smallest possible tail, so should I override T4 with AI? Should I override T4 with AI? I will override T4 with AI only when AI is less than T4, and AI is less than T4, definitely less than T4. Why? Because while going till T3, while traversing till T3, I asked T6, am I greater than you? T6 rejected that you are not greater than me, you are less than me. T5 says that you are less than me. T4 says you are less than me. Then only I reached T3. I reached till T3 only when all these tails are greater than AI. So I can definitely say that I got a new tail for subsequence which is less than T4. So what I'll do, I'll just simply replace this T4 with AI. You got it or not? We will traverse from right to left, and we will ask all the elements. Am I greater than T6? No, I'm not greater than T6. Am I greater than T5? No, I'm not greater than. Am I greater than T4? No, T4. I'm not greater. T4 is greater than AI. So then only I reach T3. And on appending AI to this subsequence of length 3, I got a new subsequence of length 4. And length 4 is in right side. And we in right side, we already checked that all the element in right side are greater. That's why I have reached here. That's why I have reached here. So I will replace this T4 with AI, which is the more smaller tail for the length of subsequence 4. Now, one thing you observe here that if I do expansion through this mechanism, I will traverse from left to right, and I will keep on moving from right to left till I don't get any element which is smaller than me. So in that way, I have segregated my array in two parts. So let's say I have these tails are greater than AI, and these tails are smaller than AI. So whenever in my tail array, this is my tail array, let's say, this is my tail array, and this is my AI element. What will do? I will start searching from this element, and I will find that element which is just smaller than AI. Now let's say I get here, so I will definitely say that these are the element which are greater than AI, and these are the element which are smaller than AI. These are greater than AI, these are smaller than AI. Because if I do insertion in this method, this mechanism, let's say I will try to expand the maximum possible array, then 5, then 4, then 3. When I got first smaller element, then I will expand that. In that way, I can always say that if I insert a new value, so I will insert AI here, right? So all these elements are less than AI, all these elements are greater than AI. Similarly, I will insert new tails. So through the same mechanism, this tail array has been prepared till now, and I will follow the same method. So by this argument, I can say that at any instant of time, I will get these tails in sorted order. Let's try run it for an example. Let's try run it. Let me take an example for you. If I take the values, then it will be more clear too. Let's take the test case from Geeks for Geeks only. Okay. Let's take this smaller one. Okay. Now here we have this array 5, 8, 3, 7, 9, 1, and let's say I will store tail in this my tail array. This is my tail array. I will store my tails here. Tail array. Okay. Initially, when I start traversing, I was not having any tail, and I will reach this first element 5. Now we don't have any tail, so this element 5 will make a subsequence of length 1. So I'll just place 5 at index 1, because we got a subsequence of length 5 or length 1, and that has tail value 5 only. Okay. Now I will traverse to 8. I traverse to 8. Now I will check, is 8 greater than 5? No, 8 is not greater than 5. 8 is not greater than 5. Okay, so I'll traverse right to left from this direction. Is 8 greater than 5? No, 8 is not greater than 5. But after 5, we don't have any element. Okay, but so 8 will make its single length subsequence. Now 8 will make a subsequence of length 1, and we already have a subsequence of length 1 here, right? We already have a subsequence of length 5. Okay, sorry, I did a mistake. 8 is greater than 5, yeah. 8 is greater than 5. So 8 is greater than 5. So 8 will expand this subsequence. 5 comma 8 will become a new subsequence. So since 8 is greater than 5, I can append it, and on appending it, I will get a new subsequence of length 2. So I'll at index 2 I will place 8. So 8 will become tail of this subsequence, 5 comma 8, right? Now I will traverse to 3. At 3 I will compare 3 to 8. Is 3 greater than 8? No, 3 is not greater than 8. 3 is not greater than 8. So I will move further in my tail array. I will reach to 5. Is 3 greater than 5? No, 3 is not greater than 5, right? 3 is not greater than 5. So I will reach here at the leftmost position where we don't have any element. So all these tails are greater than 3. So 3 will make its individual subsequence of length 3. So I can replace, but we have already a subsequence of length 1 which is of 5, and we got a new subsequence of length 3 which is of length 1 which have 3 only, and it has tail value 3. So what will I do? I will replace 5 with 3, because we got a new subsequence which is of length 1 and which has a tail value 3, and 3 is less than the already tail we are having at index 1. So I will replace 5 with 3. Okay, now I will move further. Now I have 7. Now I have 7. Okay, for 7 I will ask, is 7 greater than 8? No, 7 is not greater than 8. So I'll move to 3. Is 7 greater than 3? Yes, 7 is greater than 3. And at this position I have a subsequence of length 3. So if I append 7 to 3, 7 to the sequence of length 1, then I'll get a subsequence of length 2, because 3 signifies that I am a tail of that subsequence whose length is 1. Okay, so we don't have any element here. So I will append 7 here, and that will become a subsequence of length 2. So I can, but at index 2, we already have an element that is 8. So I should replace this 8 with 7. So I will replace it with 7. And we got it that since I traverse from right to left, so I do not need to check that 8 is less than or 7 or not, because I came till 5, till 3 after rejecting 8, right? So we have tail 3 and 7 till now. Now I'll go to 9. For 9, I'll check, is 9 greater than 7? Yes, it is greater than 7. So it will expand it, and we'll go to length 3 subsequence. So 9 will be placed here. Now I'll traverse to 1. Now I'll check, 1 is greater than 9? No. 7 is greater than 1? No. 3 is greater than 1? No. So it is less than all those elements. So 1 will make subsequence of its own, single length subsequence whose length is 1, right? But we already have a subsequence that is of length 1, and the tail value is 3. So this tail must be updated with 1. So you are seeing that at any instant of time we are getting these tail values in sorted array. Initially we had 5, then 5, 8, then 5, 3, 8. Then it is also increasing order. It is also increasing order. It is also increasing order. Then we got 3, 7, increasing order. Then we got 1, 7, 9, which is also of increasing order. So at any moment of time you are getting this tail array in sorted order. So let's wind up by writing the final pseudocode. So in final pseudocode, what we will do, we will create an array. you will create an array tail. Okay, and initially it is empty, it is nothing, it does not have anything. So, and let's say my array on which I have to find the subsequences is ARR, which is filled with some elements, right? Which is filled with some elements from A0 to AN-1. Now what I'll do, I will traverse from first of all, I will just push the first element ARR 0, because that will make a subsequence of increasing subsequence of length 1, and that will place that index 0. So here index, so how will you get the length? Because we are having index 0 based index in C++ and Java, so you can just do index plus 1 to get the length. Just do index plus 1 to get the length. So we'll traverse from I is equal to 1 to n-1. Now if my ARRI is greater than last element of this tail, how can I find the last element? I'll just do the tail dot size and -1, that will give me the index of last element. So if it is greater than last element, then I will expand the last element, last subsequence. So in that case, I'll just have to push ARRI to my tail array, because that will increase the. But what is the length? Length is this tail dot size. Length is tail dot size, right? Index plus 1 is length, and on appending the ARRI at last position, I will get the subsequence of length tail size plus 1, and I don't have any index for that, so I'll just have to push the new element there, right? Else, if that is not true, now since I know that tail is in sorted order, so I can just apply binary search, use binary search to find element to find tail which is just greater, just greater than ARRI. Then what will you do? Let's say you get the index of that just greater element in tail array. In the tail array, you will apply the binary search. So you will apply binary search. You will implement binary, or you can use STL collection framework for binary search. Use the binary search algorithm and find the index of element that is just greater than ARI. Okay, because every time we are replacing the element which is just greater than my ARRI. So if I get the index by binary search, then I'll just have to do tail. I have to override it with ARRI. Okay, this thing I have to do. Eventually, when all these iterations get over, my answer will be tail dot size. Why? Because in my tail dot size tail array we have subsequences of length 1, 2, 3, so on to maximum length I get, and the maximum length subsequence is only present at the last index, and its length is equal to its index plus 1 basically, and so index is tail dot size -1, so I'll add 1 to it, I'll get tail dot size, which I can return. So this will be my answer. I hope you got it. If you want this PDF and the working code, I'll just provide it in description.